Israel's foundational defense strategy, built on pillars such as deterrence, early detection, and strategic depth, is currently adapting to new threats faced by next-gen objects in the sky. For decades, the strategic calculus focused on major nation-state threats, such as jet fighters and long-range ballistic missiles. However, the modern battlefield in the Middle East has been changed by ubiquitous, low-cost drones and unmanned aerial vehicles. This is because drones offer a new military and economic challenge never before seen by the IDF. First, let's look at cheap dual-use quadcopters, which can be assembled for military purposes for about $500. To deploy kinetic strikes against these targets, you need to have line of sight, and soft kill strategies such as jamming have a limited range of just a few kilometers. We also need to think about certain fixed-wing long-range kamikaze drones, such as the Shahed 136 loitering munition. These high-end drones, which are sourced from Iran and used by groups in Iraq and Yemen, can cost anywhere from $20,000 to $50,000 per unit. Now consider the defense cost to shoot down one of these drones with a $100,000 Tamir interceptor. Economically speaking, this is a strategic losing equation. This warfare problem is known as the cost-exchange ratio problem, and multiple developed nations are grappling with this new problem presented by drone swarm attacks. And the financial investment disparity between the side sending the drones and the side tasked with neutralizing them is the reason why countries like Israel and Ukraine are living laboratories for counter-UAS technology. This need requires extensive layered defense in depth. Today's counter-UAS system relies on three main pillars. The first pillar is sensor detection. Systems include ELTA's multi-mission radar, which is used on Israel's primary air defense systems, the Iron Dome and David Sling. Additionally, Rafael's Drone Dome is a dedicated, localized C-UAS system that targets and neutralizes low-altitude, small quadcopters. The second pillar is the C4I strategy, which calls for AI systems to gather this information and present it to command units in order to enable them to make rapid and informed decisions. This C4I strategy takes sensor data from many different sensors in order to paint a highly accurate battlefield image. Finally, the effectors layer uses soft kill systems such as Rafael's Drone Dome to take out drones using radio frequency jamming and cyber takeover. It also uses hard kill kinetic options such as smart shooters, high-powered lasers, and integrated cannons to physically destroy the enemy asset. This entire setup is designed to prevent the most expensive mistake, which involves scrambling a jet or a helicopter to go up and chase these drones. These pillars and the entire C-UAS network hinges on the ability to compress the decision cycle. Let's go over the two frameworks that come into play here, C4I and the OODA loop. C4I stands for Command, Control, Communication, Computers, and Intelligence. It is the network backbone, the digitized system that ensures network superiority by connecting all sensors to all effectors. The purpose of C4I is OODA loop compression. The OODA loop is a military decision-making model that stands for Observe, Orient, Decide, and Act. C4I assists in the decision-making within this process. Zooming in now to see how these detection systems are deployed across the battlefield to assist, the counter-UAS detection layer is built on three overlapping eyes, which are deployed on both mobile and fixed platforms. The first pillar is long-range radar, which is handled by systems like the previously mentioned ELTA multi-mission radar. This system is truck-mounted for tactical mobility and provides long-range aerial surveillance. This system's sophistication lies in its micro-Doppler signal processing. This special algorithm filters out natural clutter like birds and identifies rotating propellers, which give off a unique frequency. This all culminates to precise classification and a lower false positive rate. Each of these sensors serve a specialized purpose within the system. Radio frequency and SIGINT sensors are used to map and monitor drone communication frequencies, while electro-optical and infrared sensors are used for visual tracking. Both Rafael's drone dome and Elbit's redrone solution use these sensors to defeat small, low-flying drones. The final pillar is sensor fusion. These various data streams are fused together via the C-UAS system. The ELTA MMR is designed to provide this fusion at the sensor level, giving command and control a clear and reliable picture of the battlefield. It's also important to note how important AI has become in this process. The moment a drone is detected, AI starts to take over. These systems, whether it's ELTA's Counter-UAS swarm solution or Rafael's C-UAS center, apply machine learning to provide near instantaneous decision support. Detection of these high-speed fixed-wing targets, such as the Shahed 136, can be classified within 3 seconds with a 96% accuracy. Once a bottleneck, this process has become seamless thanks to AI. AI executes risk-based mitigation. It sees the drone, it classifies the drone, it projects its trajectory, and predicts its intent. These systems can then generate a ranked list of optimal countermeasures based on 2 factors: probability of success and collateral risk. This also leads to strategic interception response based on the situation. When operating over urban environments, a soft kill option is preferred. But when protecting the border, the C-UAS system, for example, will prioritize speed and go for a kinetic kill. Now let's analyze how this area of battle will continue in its evolution moving forward. Once directed energy weapons like the Iron Beam become more efficient, they will reduce the cost to down these drones to mere dollars, definitively solving the cost exchange ratio that is presented by Counter-UAS. Furthermore, militaries are moving towards swarm-on-swarm engagement. This involves using AI-controlled interceptor drones or net guns to down attacking enemy drones. This adds a whole new level of automation to this facet of the battlefield. It's important to keep monitoring this space as developments continue to come our way. To wrap up, successful defense against enemy drones means the triumph of information technology over brute force defense. This counter-UAS strategy is critical for Israel's military doctrine. The goal is to achieve OODA loop compression through AI-driven C-UAS systems that achieve sensor fusion, like ELTA's MMR, that also leverage flexible effectors. This all boils down to one simple economic principle: be cheaper than your competitors, or in this case, your enemies. Making your enemies' weapons financially unfeasible is an excellent form of deterrence. That way, the battle is won before the first drone crosses the border. Thanks for watching.